All right, welcome back to Machine Learning 1, Lecture 19. This is Northeastern University course, DS 4400. Today we're going to talk about the two types of clustering that's really easy to do. Two of perhaps the easiest, agglomerative clustering and K-means. So this is Professor Wu. Let's get going. So we previously learned about PCA, which is a method that essentially lowers the dimension of the data while retaining its original shape. Well, PCA is unsupervised because it doesn't need labels. Now, we then learn LDA, which in contrast is not unsupervised because it needs labels. So today we're going to learn another unsupervised method without labels. And what we are going to try to do is to generate the labels. And we're going to call these methods clustering methods. So to the right, you can see we have a bunch of data, and you can visually see that we have about 5 clusters, right? The idea is to have an algorithm to automatically generate labels for them, such that they will say this is cluster 1, 2, 3, 4, 5, right? Once you have generated these labels, when you get a new point, you can then say, oh, this one right here belongs to cluster 1. So clustering, if you have data that doesn't have labels, you can view clustering as a way of generating the labels. Okay? And the idea of generating the labels when there are none is clustering, and we're going to talk about two of the most basic methods, Kmeans and the agglomerative hierarchical method. So the idea of clustering is to identify the concept of similarity, where if 2 points are similar, or they're in a way they're similar in location in space, right? So these two are similar in location in space, and they're close to each other, then we tend to like to cluster them together. So K-means the first one. K-means is perhaps like one of the easiest, and it's very fast to implement. So the first step to K-mean is to choose a reasonable K value. K is the number of clusters. So in this particular case, I'm going to say that there are 2 clusters, and therefore K is equal to 2. Okay? Once you start with K equal to 2, right, that means you're going to pick, that means you have 2 clusters. And for each cluster, there will be a center of that cluster. And we simply just pick 2 samples as a starting point. So let's say I pick 2 samples such as B and C. So we're going to say this is the center of the cluster for 1, and this is the center of the cluster for 2. So at this point, once you know the center of the cluster, you're essentially able to identify the points closest to the center. So here you can say that A is closer to B. Therefore, the 2 of them belong in the same, right? And for these points here, they obviously are closer to C than to B. Therefore, all of these belongs in the cluster. So remember, the first step is to just pick 2 points as the starting point, as the center of the cluster. Once you have the center of the cluster, you can identify the points that belongs to that center by distance. So this is the closest, so this belongs to this one. And these are the closest, then that belongs to class 1. Okay, now the first step, let me write this down. First step is to pick center. So get the center. The second step is to identify samples. Identify samples of each center. So, okay. And then you go back again. So you basically just do 1, 2, 1, 2, 1, 2. So now that we know the cluster, right? So cluster 1, cluster 2. So there are 2 clusters. We identify the center again. So the center of this cluster is right here. And the center for this cluster is roughly right here. Right? So now we have the new center. Now that we have the center, we identify the samples that's closest to the center. So from here, we will say that A, B, and C are closest to this point. And I will say these points are the closest to this point. Okay? So right here, as I showed you, once you calculate the center, which you find the average point, you have the average point, and now you go and calculate all the distances. Once you calculate the distances, you will say that this whole thing belongs to one single cluster, and this whole thing would belong to the one cluster. Okay? Remember, the reason why we said that is because these distances are closest, and these are the closest. Okay? Once you identify the points that's closest to your center, then you have it. Again, now that we have this point and this cluster, we again calculate the center. Once we calculate the center, which started from here, we'll move to over here. Again, the center started from here, but once you have the new cluster, then you will shift here. Now that you have the new center, you again identify all the points. So all the points are going to be here, all the points are going to be here, and therefore the center actually doesn't move. If the center doesn't move, that's when you know your algorithm has converged, meaning it's not going to change anymore. Notice how the center is just never going to change. The center is never going to change. So how do we find the distance between 2 points? Well, the distance between 2 points is the key, right? Because we need to find distance between these points, right? These points. So it's just L2 norm. Here's the L2 norm. Okay? Now, in the event when you have a point like here, and therefore C and A are equal distance, then how do you know which center you will pick? Or let's say you have 2 centers, E and D. I think the example is E and D. These are the 2 centers, which implies that F, the distance is the same, right? So how do you know how to classify F? Should F go here or should F go here if the distance is the same? Well, in this case, you can just randomly pick one. Because the distance is the same, it won't matter. So you can just put it into E if you want. And later on, it will self-correct. So, the K-means algorithm in summary. You start by picking the number of clusters, which is K, right? The value K. Once you know K, that means you pick the K number of centroids. The centroid is the middle of the cluster. So you pick K samples and use that as the starting point for the centroid. The centroid represent the separate classes with its own label. For example, we have K equals to 3, then the centroids can be labeled 1, 2, 3, for example. And then we just repeat 2 steps. Measure the distance between each point to the K centroids. If the data point is closer to the centroid, assign that point to have the same label. Once you have all the points assigned for each cluster, then you find the center of that cluster and make those points the new centroid. And that's it. So you just go back and forth. You find the points that's closest to generate your new cluster. Once you have the new cluster, you find a new center. Once you have the new center, you find a new cluster. And you just do that over and over again. And once the center stops moving, that's when you know you have convergence. Now, you might ask, how do we choose the number K? Right? How do we choose the number of clusters? Well, the easiest way, if you can visualize it, you can just look at it and notice that it's 2 clusters. However, in higher dimension, you can't. So what you do is you just pick 1, 2, 3, 4, 5. You do a whole bunch of them, maybe to some value. Once you do that, you do the clustering for each one of them. So let's say we have this example here. We have 2 clusters. Right? After that, what you can do is you can measure the average distance to the cluster. So if you did a good job, the average distance should be low, right? So over here, you can see that if you start with 1 cluster, 2 cluster, you'll go down very fast. Then you go to 3, it goes down even faster. However, there gets to a point where your growth, your decrease is not that much anymore. And when that happens, we call this the elbow. So if the distance from the center is not dramatically decreasing anymore, that's when you know that's around here is a good point to stop. And therefore, this right here would be the number of clusters you might want to use. So K-means is actually quite useful for image segmentation. So here's the image. You can essentially see that you can just separate them into different regions. The wall, the building, the grass, the water, right? So, and after you have segmented the image, that's when you're allowed to find shapes, right? So maybe you're on a street and then you see a segment of a person, and then you can separate out the background and the person and identify that indeed this is a person. So with K-means is a really easy algorithm, and if you have sklearn, it makes it even easier, where you essentially have K-means. Yeah, you just call the command K-means right here from sklearn. And then you fit the data, and you just generate the labels for you automatically. And once you're done, you're able to find the cluster centers. All right, so over here, I want you to practice the K-mean algorithm. Like, I want you to step through it step by step. And once you've done that, once you've done it step through step, you should find the center yourself and then figure out the clustering. So that's the first one, and we'll continue